Hello everyone, this is Akansha Bharti studying in 8th semester ECE, Sri Venkateshwara College of Engineering. Our today's explanation is about transferable knowledge for low-cost decision making in cloud environments. These are the content of today's agenda. We'll first go through introduction, then literature review, objectives, methodology, result, advantages and application, and in last, conclusion and references. Coming to the introduction, infrastructure as a service, cloud computing provider offer a scalable and flexible infrastructure to deploy and manage application and service in the cloud. However, selecting the best IaaS cloud computing provider type for optimal performance and cost can be challenging, especially in cloud environments where data distribution and feature space may vary significantly. To address this challenge, machine learning can potentially underpin intelligent and data-grounded decision support system for cloud computing provider and instance type selection. However, traditional ML approach may not be suitable for multi-cloud environment due to data distribution and feature space variation. To overcome this limitation, transfer learning can be used to reduce the training overhead by using existing knowledge from similar tasks to improve accuracy of ML model. TL-assisted scheme can potentially help to overcome the challenges of selecting the best IaaS cloud computing provider and instance type for optimal performance and cost. TL is categorized into two subtypes. Inductive TL aim to improve the learning of target predictive function with the help of source tasks, considering that the source and target domain are the same but the tasks differ. Transductive TL aim to improve the learning of the target predictive function with the help of knowledge from the source domain, where source and target domain may or may not be different, but the tasks are the same. The general goal of TL is to use previously learned knowledge to solve a problem in an unseen environment or in a fast or better way. TL extracts knowledge from one or more source domain and applies that knowledge to achieve tasks in the target domain. So basically, we are going to see the challenges that user of infrastructure as a service face when trying to select the best provider and services for their cloud application. To address this issue, a decision support system is proposed, which uses observational data to create predictive model for optimal deployment of cloud applications. However, generating prediction model for each new application and cloud infrastructure is time consuming and costly. To overcome this, we introduce transfer learning approach that transfer knowledge gained from running an application on a specific IaaS provider to create prediction model for new application and infrastructures. This TL approach reduced the time and the cost of generating new prediction model by 60% as evaluated under various cross-application scenarios. Overall, the TL approach provided a practical solution to reduce the overhead of deploying new cloud application on different IaaS provider. Now, we'll go through the literature review. The first paper we refer is the effect of Amazon Web Services on cloud computing, which is published in year 2021 and published by Taranjot Singh. In this paper, AWS had a significant impact on cloud computing, making it more accessible, affordable, and flexible for business of all sizes. AWS have been the key driver of innovation in cloud computing, providing business with the tools and resources they need to build to deploy application quickly and easily. The second paper we have gone through is cloud computing based learning web application through Amazon Web Services in the year 2021. So in this paper, we have gone through developing a cloud-based learning web application through AWS can help to improve the performance, scalability, reliability, and security of the application while reducing the cost associated with development and deployment. The next paper we have gone through is Multi-Cloud Resource Management Review and Future Directions in year 2020, which is written by Alok Kumar and Rajkumar Bhuya. This paper provides a comprehensive review of multi-cloud resource management techniques. It discusses the challenges of selecting the best cloud provider and instances, type for optimal performance and cost, and propose various solutions for these problems. Objectives. Now we'll go through the objective. Like our first objective is to understand the cloud computing provider and instances type for optimal performance. To analyze different pricing model offered by cloud service provider and to choose the most suitable pricing plan. The next is to develop intelligent and data-grounded decision support system for cloud computing provider and instance type selection using TL-assisted scheme. And the next objective is to reduce the overall cost of the computing service while maintaining optimal performance level by selecting the most cost-effective cloud provider and instance. Now we'll go through methodology. Tamakon is efficient, generated a prediction model for a given application, and the process starts with the collection of auxiliary data. So the main aim is to enhance the efficiency of intelligent decision support system by using existing knowledge through transfer learning, the use of semi-supervised learning, and the ability to use auxiliary target data for the model generation, an important feature of the approach. Now, coming to the block diagram, this block diagram is the architecture of Tamakon, a novel TL-assisted cloud DSS. It had three phases: analysis phase, learning phase, and planning phase. We'll go through each phases in the next slide. Here, analysis phase. It is responsible for providing auxiliary data to be used by the learning phase. The auxiliary data is collected by running the application on representative set of virtual machine and profiling different matrices related to effective action and performance of the application. Analysis phase, the application is run on representative set of virtual machine to collect data on various matrices such as CPU usage, memory usage, network traffic, and response time. Coming to the second phase, which is learning phase. To collect auxiliary data is used by learning phase to generate a prediction model for the target domain. The learning phase is composed of 4 submodules. Each module have a unique task to perform to support model generation. The auxiliary data is used by similarity method to look for the similar app location in the knowledgeable base. Based on this similarity, Tamakon transfer existing knowledge used two more TL scheme, which is designed to satisfy the goal and enhancing learning efficiency and generating the prediction model for new application. Model training uses training dataset, which may be composed of source and target domain data depending on the active mode. The test data set for model assessment is composed of the target domain data only. Model assessment is performed use tenfold cross validation, and if the output is not satisfactory, the process restart by fetching the next most similar application from knowledgeable base. Coming to the next phase, which is planning phase. The accepted model is saved in the function repository to use by the planning phase to predict future application performance. The planning phase is to be used to predict future application performance. Deployment costs are generated from the prediction to find the best deployment match in accordance with the customer specified. And in last, we'll compare and choose the best fit for the customer specified. Coming to the result of applying transferable knowledge for low-cost decision-making in cloud environment uses framework like Tamakon can be improved decision-making, increase efficiency, and cost savings. By using a systematic approach to deprogramming and knowledge transfer, organization can be better understand the relationship between different factors in the cloud environment and make informed decisions about resource allocation, capacity planning, and workload management. This can lead to more effective use of resource, reduce waste, and low cost. In addition, The use of framework like Tamakon help organization to build a shared understanding of the cloud environment among both experts and non-experts, promoting collaboration and improving communication. This can lead to more efficient decision making and better alignment between different team and department with the organization. So, overall, the result of using transferable knowledge for low-cost decision making in cloud environment is improved performance, increased efficiency, and cost saving, of all which can contribute to overall success of the organization. Coming to the next, which is advantages and application. So, advantages is cost saving. The primary advantage of cost saving decision making in cloud environment is cost saving. By using cloud service, companies can avoid the upfront cost of purchasing and maintaining their own hardware and software. Scalability. Cloud service offer the ability to scale up and down resource as needed, providing businesses with flexible and agility. Accessibility. Cloud service can access from anywhere with internet connection, allowing the remote work and collaboration. Security. Cloud service provides often have a robust security measure in place, providing a level of security that can be different from business to achieve on their own. Coming to the application, so we can use it for the businesses. Companies can transfer knowledge to make cost-effective decisions while using cloud computing service for their operation. This can help them to optimize their resource, reduce expenses, and increase their profits. And the next application is it can be used for the healthcare. Healthcare provider can use transferable knowledge to analyze large data set of patient information to identify pattern and make more informed decision about patient's care. And next, it can be used for the finance. Financial institute can use transferable knowledge to analyze market trend, access risk, and make informed investment decision. Coming to the next, which is conclusion. So, in conclusion, Tamakon is a novel solution that aims to increase the efficiency of decision support system in making application-specific decision in a cross-cloud environment. The problem of decision making in cloud environment is challenging due to wide variety of infrastructure as a service offering service offerings, which can confuse customer without much knowledge about selection criteria. The proposed solution uses transfer learning to identify the type of knowledge to be transferred and methodology to identify similarity between different sources of knowledge. Kamagon does not use pre-trained model, but instead train its function over the source and target application data. The evolution of Tamakon involves two public cloud providers and three applications of varying architecture. The results showed a significant reduction in the model generation overhead of 60% in terms of time and cost, making DSS more cost effective. The contribution is also applicable for multi-cloud brokers in considering a large amount of deployment option. Coming to the next, these are the paper we have taken as a references. Thank you very much. And this will be the future work. The future research can build on Tamakon framework by exploring unsupervised transfer learning technique and extending the study to deal with multi-criteria decision making. Additionally, expanding the approach to other categories of application and cloud providers can improve generality of approach. Thank you very much.